Hi guys. All right, let's get right into it. We're looking at worksheet week 33, sheet 1, 2 of 3. We're going to be going over the basics, introductory to probability. I'm not going to go through every single topic in the Algebra 2 curriculum, but I will go over the majority of what you need to know, because keep in mind that you do still need another semester in order for you to complete the course. So if you see me bounce around that's in a way that's different from the curriculum, just please understand that. Okay, I'll start off just by reading this. This is pretty easy. This is a pretty simple sheet, guys. I believe I gave you two sides for this. Right, I think I'll do up to problem 2. Sorry, up until exercise 3. Exercise 3A and maybe B. All right. So we can start off by reading this. Basically, what probability is, guys. It's the probability of a certain event happening over the total number of outcomes, right? So you want to be able to have the event over the outcome, or the full sample space, what's known. All right. So mathematics seeks to quantify and model just about everything. One of the greatest challenges is to try to quantify chance, but that is exactly what probability seeks to do. With probability, we attempt to assign a number to how likely an event is to occur. Terminology in probability is important, so we introduce some basic terms here. Experiment, some process that occurs with well-defined outcomes. The outcome, a result from a single trial of an experiment. An event, a collection of one or more outcomes. And a sample space is a collection of all of the outcomes of an experiment, right? So the sample space is your denominator, essentially. And the event will be your numerator. So if we're looking at it like that, and we try the first problem, exercise 1, which says an experiment is run whereby a spinner is spun around a circle with 5 equal sectors that have been marked off as shown. What is the experiment? The experiment is to find so the experiment is getting an outcome from this spinner, right? So when we defined an experiment before, it said some process that occurs with a well-defined outcome. So in this case, our well-defined outcome would be either the spinner landing on 1, 2, 3, 4, or 5, right? So that's the experiment. The experiment is spinning the arrow around so as though to find the outcome of either 1, 2, 3, 4, or 5, right? Then B says give one outcome of the experiment. Well, one outcome of the experiment is hitting a 1 or hitting a 5, right? Or hitting a 3. Those are one of the outcomes, right? Then it says, C says, what is the probability of spinning the spinner and landing on an odd number? Well, and there's how many odd numbers from 1 to 5? There's 3, 1, 3, and 5, right? And what is the event here? Again, the event is a collection of one or more outcomes, right? So the event here is going to be 3 over 5. What outcomes fall within the event? Well, it could be 1, or the outcome would be all odd numbers in this event. See if that helps you out a little bit. You don't see generally questions like this, guys. You will see a little bit easier or harder questions. Those questions include probability, like what we see in exercise 2. And in exercise 2 says the basic definition of probability. Probability of an event E occurring is given by the ratio PE equaling NE, which is the number of outcomes that fall into an event E, and NS is the number of outcomes that fall into the sample space, right? And keep in mind, the sample space is our total amount of outcomes that we can achieve. So if we go from there and look at exercise 2, it says, given the above definition, between what two numbers must all probabilities lie, right? So between what two numbers? Well, all probabilities have to lie between 1 and 5, right? That is how it's defined, right? Any questions on this so far? Let's see who else came in. All right, so this is probably going to be archived so you guys can look at it later. In regards, I am going over sheet 33, week 33, sheet 1, which is for any normal YouTuber on my channel. It's an introduction to probability. This is a common core. This is an e-math instruction. It's a site you can go. This is the first sheet, common core algebra 2. Okay, so then let's go on. If we go on, we see on the back side of that sheet, right? So let me go take a snippet of that. Hold on one second, guys. Right here. We're just going to do up to 3B. So let me take a snippet of this right here. Just get rid of this for a second. New. Okay, really close. Kids in the backdrop. You know how real this is. Go here. First we include this page. Right here. Okay. So now we begin. It says when we deal with theoretical probability, we don't actually have to run the experiment to determine. Hold on one second, guys. All right. Sorry. So it says when we deal with theoretical probability, we don't actually have to run the experiment to determine the probability of an event. We simply have to know the number of outcomes in the sample space and the number of outcomes that fall into our event. Let's take a look at a slightly more challenging scenario. Again, this is the backside of the sheet that I did assign to my class, which is what I'm going over on this channel right now. And one of the most famous examples that you would see in any college curriculum, as well as any Regents exam or state exam you may be taking, is an example like example 3. It says a fair coin is flipped 3 times, and a result is noted each time. The sample space consists of ordered triplets: heads, heads, tail, which would represent a heads on the first toss. One more second, guys. Sorry about that. Okay, so now we're looking at this exercise 3. It says a fair coin is flipped 3 times, and the result is noted each time. The sample space consists of an triples. I know I read this before, guys, but I just want to be able to just make sure you guys understand this. Such as heads, heads, tail, which would represent a head on the first toss. A head is on the second toss, and a tail is on the third toss, right? Draw a tree diagram to show all the different outcomes in the sample space. Well, okay, so it says a fair corner is tossed 3 times. So let's look at all the sample space. On the first attempt right here, get rid of that. Yeah. Get rid of this right here. Okay. Okay. In the first attempt, right? Second attempt. And third attempt. All right, so in the first attempt, we have heads, tails, right? And the second attempt right here, we can't possibly have heads and tails. Again, we can have heads and tails right here. In the third attempt, again, we can have heads and tails. Heads and tails. Heads and tails. Heads and tails. Okay, so that's what we can get with every single one of our attempts. So the sample space, we just list out all the attempts we can have in the first try, second try, and so on. Let me show you guys right here. So if we're looking at green right here, I might just be able to do 3A with you guys, all right? So we'll put sample space right here. So we have H. We'll have H from here to here. Right? So it's going to be H, H, H. Right? Then we have H, H, T. Then we have, everyone see that? I don't know if you guys can see that, right? H, H, H. Then you guys can see then in the next attempt, it would be heads, tail, heads, then heads, heads, tail, tail, right? That's if we start off initially with the head. I'm gonna see where I'm getting at. If you just follow the path, right, of what I'm doing right here, I'm trying to make it light blue. Right, so the next one would be tails, heads, heads. I don't know if you guys see it there. See it there. The thing is, if I actually draw a line through it, it'll erase it. Let's see right here. Then that would be tails, heads, tails. Then we have tails, tails, heads, and then we'll have tails, 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 right? See you guys? I hope that's clear, right? That's showing all the sample space of the probability that you can have as an answer, right? It says list all of the outcomes as ordered triplets. How many of them are there? Well, there are about 8. There are 8 outcomes as ordered triplets. All right? Then if you look at C, would just be find the probability of getting all heads. Well, there's one with getting all heads, and the total outcome will be my denominator, so that would be 8. And the probability of getting that exact what do we call it? What do we call it? Problem of getting that event would be 1 over 8. So 1 over 8. Exactly 2 heads. So we're looking for exactly 2 heads. Well, we have this right here. We have this right here. We have this right here. And we have, well, that's 22. Okay, so that's just 3 over 8. Then we have all heads or all tails. All heads or all tails. So all heads would be all heads would be or. Remember or. So so you can potentially get both. Right? So all heads or all tail. All right. So all heads would be right here. So it's 1, and then all tails would be TTT. So that would be 2 over 8. Right? So that's generally the probability that we can actually get these events, all right, guys? I do have to try to cut it short just a little bit because of my daughter with me. But if you have any questions, guys, please leave a comment in the section below, or leave a comment on the stream of the Google Classroom. All right, guys? If there's no questions, I'm going to move on, and I will see you guys again on Thursday. All right, please use this as a reference for the new sheet that I just assigned.